In this video, we're going to learn how to solve a real-world problem with a three-variable system. For this example, you manage a clothing store and budget $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy? So there's, again, lots of information to decipher, so we're going to break this down little by little. First, we want to make 200 shirts. So if we add all of our t-shirts, polo shirts, and rugby shirts together, that should equal 200. Now let's talk about our budgets. We know that t-shirts are $12 each. So $12 per t-shirt plus $24 for every polo shirt. So 24 times polo shirts. Plus $36 per rugby shirt. So 36 times the rugby shirts. And altogether, I'm looking to spend $6,000. Now the last bit of information came right here. I saw that I want to have twice as many rugby shirts as I have polo shirts, which means that for every rugby shirt, or rather for every polo shirt, I'll have 2 rugby shirts. Now represent this by doing 2 times polo shirts is equal to rugby shirts. So if it's not already apparent, we're going to let X equal the number of t-shirts or let Y equal the number of polo shirts. And we'll let Z equal the number of rugby shirts. Again, since that's what we're looking for, how many of each type, it's great to have those be our 3 variables. So now let's look at our 3 equations we started to form based on the information given to us up here. This first one here would just be X plus Y plus Z is equal to 200. Then we have 12x plus 24y plus 36z is equal to 6,000. And lastly, we have z is equal to 2y. So there are all of our equations. Now, the middle equation, every term is a multiple of 12. So I can divide every single one of these terms by 12 to make it a little bit simpler of an equation. So my first equation is fine. X plus Y plus Z is equal to 200. But the next one, 12 divided by 12 is 1, so I can get X. 24 divided by 12 is 2, so 2y plus 36 divided by 12, which is 3z, is going to be equal to 6,000 divided by 12, which is going to be 500. And I'll still have z is equal to 2y. So now as I go through solving this, I can use any of the methods, but substitution seems to be the way to go. Since I already know what z is equal to, I can substitute that into my first 2 equations. So I'll let z be equal to 2y. So my first equation, I have x plus y plus z is equal to 200. But now I can write that as x plus y plus 2y is equal to 200. So give me a new fourth equation. X plus 3y is equal to 200. Now I'll also take the second equation and substitute in z. Second equation is x plus 2y plus 3z is equal to 500. Now I'll have x plus 2y plus 3 times 2y is equal to 500. Which gives me my new fifth equation to be x plus 2y plus 6y, which is 8y, is equal to 500. Now I have a new system I can work with, which is x plus 3y equals 200, and x plus 8y equals 500. Now again, another system that's set up for substitution, so I'm going to use that. I'll take equation 4 and solve it for x. And I'll get x is equal to 200 minus 3y, and I'll substitute that into my fifth equation, which is x plus 8y equals 500, which now is going to be written as 200 minus 3y plus 8y equals 500. Now subtracting 200, I get 300 on the right. And then negative 3y plus 8y is 5y. And dividing 300 by 5 gives me 60. So y should equal 60. Now going backwards, I can plug that into my fourth equation to get x. So x will equal 200 minus 3 times 60, which will be 200 minus 180. So x will equal 20. And then going back even further, I can plug in for z over here. And z is going to be equal to 2 times y, which is 60, which will be 120. So my solution to this problem is the ordered triple, 20, 60, 120. And if I want to double check, I could plug that into either of my other equations, and those do add up to 200 shirts, so that should work. But to interpret my answer, I would need to buy, I should buy 20 t-shirts, 60 polo shirts, and 120 rugby shirts. It is very important that you interpret your answer when you're solving word problems. And that is how you solve a real-world problem with a 3-variable system.